Hi everyone watching from around the world, and welcome to this keynote called Some Ideas on the History of the Universe, Cosmic Education and Why It Matters. Most people engaged in Montessori education knows the importance of teaching children about history of the universe, the earth and humanity. Our keynote speaker today, Dr. David Christian, shares this passion for teaching new generations about where we come from and where it all began. In this talk, we will hear more about his thoughts and work on this subject and why we should all care about and teach big history. David Christian is a professor of history at Macquarie University in Sydney, and he's with us today all the way from Australia. I've had the pleasure to meet David before and hear him speak passionately about this subject, and what really struck me was how many connecting ideas it was between his thoughts and the Big History Project and the Montessori perspective on this same subject. We are also fortunate to have Carla Foster with us today, and she will be David's conversation partner along the way, asking him questions and sharing her views from a Montessori perspective. Carla is an AMI 6012 trainer and holds diploma courses several places around the world, including here in Norway, where we are based right now. My name is Nina Johansen, and I'm the Executive Director of the National Montessori Association of Norway. And so I hope you all enjoy this important and engaging talk, and I will hand it over to you, David. Welcome.
Hi to Nina and Carla, and also to everyone who's listening to this, and I hope that this proves enjoyable. I'm going to launch almost straight away into my talk, and we may split it up into two halves, and Carla may ask some questions in the middle. So let me try and share, and let's hope this all works. Okay. Nina, can you see the screen okay?
Yes.
Okay, so let me go. Some ideas on the history of the universe and why it matters. Who am I? What am I part of? Where have I come from? Where am I going? These are questions you'll all know as teachers, that every smart, intelligent kid asks those questions and wants to get some sort of answers. My own feeling is that modern education doesn't do a very good job of giving answers to those questions. So I've been trying to take my own path to find answers to those questions and ways of teaching those answers. So let me begin with Maria Montessori on cosmic education, developing independence, gratitude, and a sense of community. I'm not a specialist in Montessori education, but as we'll see, my paths, I think, have gone in parallel ways to Montessori education. Here's Maria Montessori. Let us give the child a vision of the whole universe. The universe is an imposing reality and an answer to all questions. All things are part of the universe and are connected with each other to form one whole unity. The idea helps the mind of the child to become focused, to stop wandering in an aimless quest for knowledge. Now, this is something I can agree with wholeheartedly. So big history, let me explain what big history is. I'm not an expert, as I said, on Montessori education, but what I've been doing for over 30 years now, since 1989, is teaching courses in what I call big history. And I think of big history as a sort of updated version of Maria Montessori's project of cosmic education. And what I'd like to do in this talk is describe the story we tell in big history courses. And I hope you as Montessori teachers will find many interesting synergies between these two paths, big history and cosmic education. And both of them are driven by what the physicist Erwin Schrödinger called, and I love this quote, the keen longing for unified, all-embracing knowledge. So part one, the idea of a modern origin story. And in this part, I'll say why I think the idea of origin stories is important, and I'll describe the story that we tell in big history, just very sketchily. Okay, what are origin stories? Well, As I understand it, origin stories have been told in all human societies. We can be pretty sure that 200,000 years ago in the Paleolithic, people were telling origin stories. You can find them in indigenous religions, you can find them in all the great religious traditions. But as we'll see, I believe there's also an origin story lurking within modern scientific knowledge. And what these stories do is they bring together the best knowledge of a particular society, and today we're talking about today's global society, of course, the best knowledge about how things came to be as they are. They teach that knowledge in accessible and engaging forms so that everyone can know it and grasp the story. It's a way of conveying a society's best knowledge of how things came to be. And origin stories provide a sort of universal mapping so that they can help you know your place in space and time. And that can help you know the challenges you face, the tasks that lie before you. Sadly, modern schools, for the most part, do not teach an origin story. And what that means, I think, is they fail to teach young people what it is we're part of. And that, I think, is tragic. Let me give a sense of what I mean by mapping yourself onto reality. Origin stories really matter. Let's take this question, who am I seriously? Now, all of us have many identities. All of them are important, and we need to know all of them and know the links between them. For example, there's me as myself, just as an individual. There's me as a member of a family, a small, close-knit group. There's me as a member of a village, perhaps, or a clan, or a school, a closer community. Then I may think of myself as part of a nation, part of a religion, a religious tradition, or part of a civilization. Then beyond that, there's the community of all human beings. I belong to the species Homo sapiens. That's a species that's been around, as we'll see, for 200,000, perhaps 300,000 years. There may have been 100 billion humans in that entire time. I'm part of that community as well. Beyond that, I'm a living organism. So I'm part of the community of all living things on Earth. And that's a community that's been around for about 4 billion years. All living things, of course, treat planet Earth as their home. That's that community. And then beyond that, there's the even bigger community of the universe, of the cosmos. We are all part of one universe. So I hope you can see my identity consists of all of these overlapping identities. And to understand who I am, I really need to have some understanding of all of these. And what that means is I need many forms of knowledge. So let's go back again to the beginning. If we think of myself as an individual, then perhaps the appropriate knowledge is psychology, which studies the minds of individual humans. If I think of myself as a member of a group, then perhaps the appropriate knowledge is sociology or anthropology. If I think of myself as a member of a group with a history, then perhaps I'll need a national history or global studies. If I think of myself as a living organism, of course, the appropriate body of knowledge is biology or studies of the biosphere. So I hope you can see how each identity requires new forms of knowledge. And we can go beyond biology. I live on planet Earth. So to know my homeland, I need to know something about the earth sciences, about the history of planet Earth over 4.5 billion years. And then beyond that, there's astronomy, knowing about our sun, about our planet, about the solar system, and finally, of course, physics and cosmology, which teach us about the most fundamental aspects of our universe. So understanding what I am involves understanding many forms of knowledge, and it involves interdisciplinary education, a story that crosses multiple disciplines. And this is why, for many years, I've used Vincent van Gogh's painting, Starry Night over the Rhone, as a sort of icon for big history, for a modern origin story. Here's why. So if you look in the top of the painting, you'll find stars. So we're looking at astronomy and cosmology. If you look at the bottom of the painting, you'll find Earth. So we're sort of looking at geology or planet Earth. If you look over the right, you'll see water. Now that's where chemistry happens. It's probably where life formed. So we can think of that as a symbol for chemistry and biology. Over here, we see lights, we see buildings. So this is anthropology, this is history. We see cities, churches, human civilization. Down here, we see modern history. We see science and technology, electric lights and modernity. And some of you will have already noticed what's missing from this picture. What's missing is you and me trying to figure out our place in the universe. So I think Van Gogh's painting is a lovely icon for big history, or for the idea of a modern origin story. If you put all these stories together, you get a modern origin story. Now the idea, this over the left, sorry, this is shameless advertising. This is my book, Origin Story, which has been translated into a number of languages, including, I know, German and Swedish. I don't believe into Czech yet, but the idea of building a modern science-based origin story is probably about at least over 200 years, 300 years old, really. It's existed since the Enlightenment. And for some thinkers, it went back before then. The idea was, can we build a modern origin story that's based on modern science? Now, why return to this project today? Well, one reason is that in the late 19th century, the idea of building a modern science-based origin story sort of broke down. It was abandoned. And I think the reason was that the science was not really good enough. There was great progress in many areas of science, but we couldn't yet tell a coherent science-based origin story. There were huge gaps in the story. And the result was that in the early 20th century, what emerged in education and scholarship and science was a world of fragmented disciplines. Knowledge was conducted and taught within discipline by discipline. And we forgot about the links between the disciplines. There was no big story. Now, this method worked very well. There's an immense amount of new knowledge was gained in the 20th century in many, many fields, from history to geology to mathematics to cosmology. But what we lost was the unified vision of a traditional origin story. And in fact, many people began to feel that in the modern world, such a story was impossible. I think they were completely wrong. Since Maria Montessori's time, when she wrote in the middle of the 20th century, really before a lot of modern science had kicked in. Since her time, the science has got much, much richer. So we can tell this story, we can put together a modern origin story, and we can tell it rigorously and engagingly. And what that story shows us is something immensely important. It shows us the challenges we face. It shows that we live at a turning point in the history of planet Earth, and we humans are going to be responsible for the outcome of this critical moment in planetary history. And I believe strongly that we need to teach young people with a wide enough vision so that they can understand the huge challenges they face today. And that's something I'll come back to in later parts of this talk. Okay, now let me try to give you a sort of very simple feeling for the shape of the story, at least as we tell it within big history. The basic idea of the story, the basic plot line, is that the early universe was simple, but over 13.8 billion years since the Big Bang, more and more complex things have appeared, laying the foundations for today's world. Now, the early universe, we know, was very, very simple. It had very little structure indeed. To get a feeling for what it was like, think of a thin mist of hydrogen and helium atoms. There's light, photons of light pouring through them. There's dark matter, which we don't understand. And everything is almost at exactly the same temperature. How do we know this? We know this because we can study the distribution of energy in the early universe by studying the cosmic background radiation, which was emitted about 400,000 years after the Big Bang. Now, in this very early universe, it was very simple. There were no galaxies and stars, no heavier chemical elements, no planets, and certainly no living organisms or humans. It was utterly different from the world as we know it. Then, and this is the story, over 13.8 billion years, step by step, more complex things have emerged. Now we need to be clear, most of the universe remains very simple today. Most of the universe is empty space. It's very cold, it's very uninteresting. But in pockets, special regions in the universe, such as our planet Earth or the early Earth, Goldilocks conditions appeared, very special conditions that allowed existing things to be rearranged so as to form interesting new structures. And these structures had new properties. We call them new emergent properties, qualities that had never existed before, such as life. When the first living organisms appeared, life was an utterly new quality. And eventually this process of building complexity on complexity led to the extreme complexity of today's globalized world, the world we all live in and our students live in. Now, this is a story, it may seem abstract, but it's actually full of meaning for us humans, because it's very much about us, because today's globalized world represents an extraordinary level of complexity. So this story tells us how we got here. Now, you'll be glad to know the story has a villain. Actually, some scientists tell me that it's not really a villain, it's a hero, but it's much more interesting to call it a villain. And that villain is entropy. Entropy is the tendency of everything to become less ordered, more random, more shapeless. And the reason for entropy is that most possible states of energy and matter are chaotic, they're disordered, they're random, they're not structured. Now, what entropy does is it tends to destroy, to break down all complex things. So here's the puzzle. Here's the plot line, if you like. The miracle is that complex entities such as stars and planets and sea slugs and humans have emerged despite entropy. Now, how is this possible? This is a very, very deep and complex question, and I'm not sure we have any decent answers, but I can give you two preliminary answers. The first is that in the Big Bang, some basic rules appeared. It's as if the universe appeared with a number of rules, a bit like chess. For example, one rule said that gravity, the force we call gravity, pulls things together. Now, these rules guaranteed that the universe would have a minimum of structure. There would be some structure in the universe. It wouldn't be completely random. Secondly, and this is more complex, and I'm not going to try to go too deeply into it, the creation of really complex things depends on flows of energy. They need flows of energy to keep them held together. Think of a modern human society. But these flows of energy tend to degrade energy and structures faster. Faster and faster, they do entropy's work. Eventually, these flows of energy tend to break things down. So that's why the force of entropy, in a sense, sustains the building of complex things, because they are doing entropy's work. So we can say that entropy is perhaps the hero of this story, because entropy generates the flows of energy that allow complex things. Now, I'm not going to discuss this anymore. It's a really deep issue, but it lies behind the big history story. Now, let me try to give you a feeling for the shape of that story. And this is at least how I tell the story. It's not the only way of doing it. There are many ways of doing it, but this is one way of telling it. I tell the story through 8 main thresholds of complexity. These are moments when something new appeared in the universe, something new with new emergent qualities. There have been many thresholds like this. Picking 8 is a bit random, but it works as a teaching device, as I've found over many years. And it takes us from the very simple early universe to the complexity of today's world. So let me just go through these thresholds very quickly. The first threshold is the creation of the universe in the Big Bang, about 13.8 billion years ago, and that's in the field of cosmology. The second is the creation of the first stars. A universe with stars was already much more complex, much more interesting, and much more diverse than the very early universe I described earlier. The first stars probably appeared about 13.2 billion years ago, and now we're talking astronomy. Inside dying stars, there appeared new chemical elements. The early universe consisted just of hydrogen and helium. Now, all the other elements, gold, uranium, silver, mercury, appeared inside dying stars. Massive explosions where huge temperatures were generated. So now we're in the domain of chemistry. That's the third threshold. The fourth is the creation of chemically complex new entities in space, planets and Earth. These are chemically much more complex than stars. Now, I hope you can see how each threshold builds on the previous thresholds. So now we're in the territory of astronomy and geology. And then the fifth threshold is the emergence of life. About 4 billion years ago on our planet, it's a good bit that there's a lot of life in the universe, but so far we only know of life on Earth. So now we're in biology. And then the last three thresholds, in the way I teach the course, are all about humans. That may be exaggerating our importance, but it's a good way of placing humans in this story. Our species, Homo sapiens, appeared about 200,000 years ago. So now we're in archaeology and anthropology. About 10,000 years ago, there was a massive change at the end of the last ice age with the appearance of agriculture. So now we can say we're sort of in archaeology or history. And then the final threshold is what I call the Anthropocene. About 100 years ago, the appearance of this radically different modern world, which is powered by fossil fuels and nuclear power. So those are the 8 thresholds as I teach the course. And it works as a pretty good way of telling this story. Now, I'd like to go back over them to give you a sense of the shape of the story. We humans are not designed to have minds that can understand what 1,000,000 years is or 1,000,000,000 years. So to get a sense of the shape of this story, let's imagine that the universe appeared not 13.8 billion years ago, but about 14 years ago. I'm dividing all of it by 1 billion. Now, so I recalculate all the dates. If the universe had appeared 14 years ago, the Earth would have existed for about 5 years. Now, in brackets, I put the real period. Life would have existed on Earth for about 4 years and 3 months. Large organisms with many cells would have appeared about 7 months, only 7 months ago. That's 600 million years ago. So most of the history of life on Earth is a history of bacteria. The asteroid that killed the dinosaurs, and I'm assuming you all know that an asteroid wiped out the dinosaurs about 65 million years ago, and that's really why we're here. That asteroid landed 3 weeks ago on this time scale. That's 65 million years ago. Our own species would have existed for about 50 minutes out of the last 14 years. Agricultural societies for 5 minutes, that's 10,000 years. The entire recorded history of civilization for just 3 minutes. Modern industrial societies powered by fossil fuels for about 6 seconds. And the Anthropocene, which is really my lifetime, for just 1 second. Now, I hope that gives you some feeling for the shape of this story. And really 2 things come out of this. The first is the Earth is about 1/3 of the age of the universe. But we humans appear very recently in this story. Human history occupies less than 1 hour out of 14 years. So I hope that gives you a sense of the shape, the chronological scale of the story. Okay, that's part 1 of my talk. And I believe that we're going to take a break at this point and have some questions. So I'll stop sharing. Okay, Carla.
All right, thank you. My first question is about when you were first developing this, you were thinking about higher education. Is that correct?
Yes. I was teaching at Macquarie University, so this was taught as a first year history course, but it attracted students from right across the university.
Yeah, so when Montessori was thinking about these things, she was thinking actually about how to communicate this to the 6 to 12-year-old who's just coming into an understanding of linear aspects of time and using their imagination to travel in time and space. And so some of the principles of cosmic education do have to do with trying to communicate simple laws that everything follows, what she calls work, that is the effect that following laws has on the environment around you, which then causes change, which on your website, you talk about both metabolism and homeostasis as being important aspects of life. And then this creating webs of interdependence, which one has to understand. So would you say that this is a big history approach?
Look, I think there's lots and lots of overlap between the two approaches. Take homeostasis. I've talked about these thresholds, the creation of new types of complexity. Once you create new entities such as stars, then they end up in a kind of complex, always slightly changing relationship with the universe. And that relationship is fueled by energy. Now, I think this is probably very close to what Maria Montessori means by work. And the webs of interdependence are clearly there, because a star consists of billions of atoms, but they are related in a structure of a very, very hot core where fusion is going on, energy is pouring out to the edges, but other atoms are drifting back in towards the center. Now, that's a fairly simple structure. Modern human societies are much more complex than that. But as we'll see in the second part of this talk, I believe that these webs of interdependence are absolutely vital to understanding what makes us humans, in many ways so different. I don't know if that's an adequate answer to your question.
Yeah, no, it's good. So also in our work in cosmic education, we try to put the physical sciences, the biological sciences and history kind of at the core of the work, and as opposed to things you do if you've got time when you're finished with your math and language. How would you respond to that?
I guess all I can say is I'm very sympathetic to that approach. I am a historian, so when I began thinking about this idea of a course on the history of the universe, I was inevitably thinking historically. And one of the things that I realized is that in the middle of the 20th century, when Maria Montessori was first writing, there were many scientific disciplines that were not yet historical. So in the 60s, biology was beginning to become historical because of Darwin's theory. Geology was sort of historical, but it didn't have good dates yet. It couldn't give you dates. Cosmology was not historical. Most cosmologists assumed that the universe was static and unchanging. Big Bang cosmology turned cosmology into a historical discipline. And then eventually we learned that chemicals have a history. In the early universe, there was no gold, there was no uranium. So chemicals have a history. So chemistry became a historical discipline. So just in the last 50, 60 years, a lot of science has discovered that there's a deep history behind what we often thought of as static knowledge. And you find stories in history. So this is very much about the historical disciplines. Yeah.
So, and you emphasize a lot this idea of storytelling as a way of helping the imagination to really grasp these giant ideas. Could you talk a little bit more about that?
Look, my wife worked for many years as a professional storyteller. And I think I learned a hell of a lot from her, because when at first I began, I was telling this in a very academic way. You know, I was giving very academic lectures, and but eventually she said, "Look, you're telling a story." And I wanted to be an actor at one time in my life, so I've always loved stories. And eventually I realized that the way our minds work, we understand things better through stories. So there's a good reason why the best way of teaching young people the most important things about your society is through stories. And that's why over the years, I've begun to more and more see big history, not just as a sort of interdisciplinary course, but as a sort of origin story for the modern era. I should add one more thing, which is that just that stories are engaging. You know, they're fun. If you want, and they're a great way of getting across complicated knowledge, because if you tell a story and there comes a point where things get a bit complicated. Now, if the story is engaging enough, then the people listening to your story, they will start thinking really hard because they will want to work their way through the details of the story. So it's just a great way of teaching.
When you said one of the keys in terms of understanding the dynamic of entropy and complexity is about rules that come about. And one of the things that Montessori writes about is how important it is for children to understand that rules are not prohibitions. In the natural world, rules are really about necessities for existence. And this does something for the moral imagination of the child as it's building in that particular time period between 6 and 12, when they really are interested in these moral questions. And yet they're often faced with a lot of rules as either just prohibitions or limits.
Yeah.
Can you talk about how shifting that focus on the idea of the rule can help change and free the mind to really think about big history?
Look, if you're a cosmologist or a physicist, I doubt if you think of rules as prohibitions, although of course they are. I know the metaphor I prefer is sort of trackways. You know, if the universe could have been just a completely random mush, like a sort of cloud with no shape at all, it'd be very uninteresting. But if what you see through that mush is trackways, in other words, wherever there's gravity, things are going to move in a particular way, not in a random way. Electromagnetism works in particular ways. So these create structures. They make it possible for things to happen, for interesting things to happen. Without those rules, the universe would just be a random mush, and there would be nothing interesting at all, including humans. So, you know, the rules of genetics make it possible for you and me to exist. They create possibilities.
That's great. Do you want to move on to your second part, and then we'll come back to some more questions?
Okay, and in the second part, what I really want to do is talk about how I think this story can help place ourselves within today's world. And I promise I'm not going to talk about the pandemic. Okay, here we go. Okay, so this is part 2 of this talk, Humans and Today's World in a Modern Origin Story. We humans appeared very late in this story, about 4 billion years after the first life forms. But we're very strange indeed. And I increasingly, as I've taught big history, have come to believe that the appearance of our species marks a turning point in the history of planet Earth. So let me try to explain why. And the real reason is that we're the first species in 4 billion years that accumulates knowledge across generations. So what changed? What changed is what I call collective learning. People give it different names. So one is just culture, cumulative learning. Let me try to explain what I mean. There are many brainy animals that can communicate. Dolphins can do it, whales can do it, chimpanzees can communicate, but the communication is very limited. And what that means is that information leaks away as fast as it accumulates. So if you watch a community of chimps over, say, 1,000 years, They may do things in slightly different ways, but what you won't see is a sort of build-up of information. There's no long-term growth of learned information. Now, humans are radically different. It's as if they crossed a language threshold. Human language allows us to communicate and to share ideas and information with a precision and a speed and efficiency that no other animal can match. And that changes everything. What it means is we share more information. That's what we're doing in this talk. This is an example of all of this. A chimp could not do this. For the first time in 4 billion years, information accumulates as we share information. It means if I have a smart idea and I tell someone and then I die, the idea will survive in the community, and ideas build on ideas, generation to generation. And it happens faster and faster as you get more and more people, until eventually it gives us more power, because knowledge is power. It tells us how to do things, how to control our surroundings, more control over energy and resources. And that, I believe, is the real driver of human history. And this process began in the Paleolithic, as soon as humans were around. And this is threshold 6. Now, let me lead you through this map. Over here in Africa is where humans seem to evolve. Now, most species, they evolve in a given environment and they stay there for most of their existence because they have a limited range of skills. Humans can accumulate more and more information. They can learn how to use more and more environments. So humans in Africa spread to coastal regions, into jungles, into desert regions, and eventually they spread out of Africa into other parts of the world, to the tundra of the Arctic, of the Arctic. They crossed the sea into Australia at least 60,000 years ago, and Australia was a completely new environment. And by 10,000 years ago, you could find humans on all continents apart from Antarctica. And what that means is that as each community acquired new knowledge, they learned how to live in many, many different types of environments. And if you put all humans together, their knowledge and power and control over resources was immense by 10,000 years ago. Then, 10,000 years ago, agriculture begins to appear. Now, let me explain why I think agriculture is such a fundamental turning point. Basically, what it did was give humans more energy. And we've seen that energy is the foundation for creating more complex things. And here's how it works. Let's go back to the sun. At the heart of the sun, you have protons fusing together. This is like what happens in a hydrogen bomb. Generates huge amounts of energy. That energy seeps out to the edge of the sun, then it pours into space. On Earth, plants capture that energy through photosynthesis. And what farmers do is they change their environments. They dig ditches, they dig irrigation canals, they take down trees. They change their environments with a specific goal in mind. And that goal is to increase the production of resources they can use. They want to increase the production of wheat, for example, or pigs or cows, and then reduce the production of resources they can't use. We call these pests or weeds. So they get rid of trees so they can produce wheat, or they get rid of wolves or foxes or rats. And the end result of this is that one species, humans, is getting more of the energy that's flowing through the biosphere. There's more food available for humans. So with more energy, more food, you get larger populations. You get more people sharing more information. Their technologies advance faster and faster and faster. You get larger societies. You get villages, towns, cities, civilizations, states, empires, all the things that historians love to talk about. And you get faster and faster collective learning. So that our technological creativity accelerates. And eventually you get what we call science, modern science. But by 1800, some people were beginning to argue that we're using all the energy that agriculture can generate, so that this process of growth is going to slow. It turned out they were completely wrong, because at the end of the 18th century, we discovered a new source of energy, that was fossil fuels. Fossil fuels are really the buried remains of plants and organisms that lived several 100 million years ago. They're buried and fossilized beneath the earth. So beneath the earth there is several 100 million years worth of buried energy. And that's what we discovered how to use in the 18th century and the 19th century. So here's a vast new bonanza of energy. And these energy flows really created today's world. Now, let's look at this graph. What it shows is the increase in energy in the last 200 years. The brown area down here is the energy available from traditional sources, from agriculture, from burning wood, and so on. All of this is energy that's become available in the last 2 centuries. And all of this is within my lifetime. This vast increase in energy. You can see how the difference between the energy available today and the energy that would be available without the fossil fuels revolution. Now, that vast bonanza has really created today's world and allowed the building of a much more complicated global system. Many people call this the Anthropocene Epoch, the epoch in which humans dominate planet Earth. Now, there are good and bad aspects of this. There's a good Anthropocene, which is what most of us are beneficiaries of. All this energy meant that each one of us had more, there was more energy available per capita. You can see that on the graph, a sudden increase in the energy available to each of us. So we can drive in cars, we can fly in planes, we can heat our houses and so on. And it's even led to an increase in lifespans. In the last 100 years, the average lifespan of humans on Earth has increased by almost 3 times. That's absolutely astonishing. And this is all because of these increased flows of energy. That's the good Anthropocenes. That's the good news. What's the bad news? Well, remember entropy. Will entropy start breaking down all the complex structures we've built? The more complex things get, in some ways, the more fragile they get. And the greater the danger is that they will break down. And there are many signs that the societies we live in today are fragile. And here's one of the most striking, and I'm sure it's familiar to all of you. This is the other side of burning fossil fuels. Now, if you look down here, the baseline, that is the amount of CO2 emissions for the last 10,000 years. And you'll know, of course, that carbon dioxide is one of the greenhouse gases. More carbon dioxide means that more of the sun's heat is retained on the Earth, and it means the surface of the Earth begins to heat up. Now, here are carbon dioxide emissions as a result of burning fossil fuels. And once again, the emissions in here are emissions that have been produced within my lifetime. Now, all of this is beginning to destabilize the global climate system in ways that are potentially very dangerous for future generations. They will undermine the Goldilocks conditions for a good human life. How significant is this increase in carbon dioxide levels? Well, here's a graph showing changes in carbon dioxide levels over the last 800,000 years. It's based on ice cores from Antarctica. Now, what you see over here, this is 800,000 years ago, but you could extend this back at least another million years. And what you see is that carbon dioxide levels have gone up and down with ice ages and interglacials, but they've always been below 300 parts per million, okay? Here's when human history begins, about 200,000 years ago. There's the Industrial Revolution, when we really began burning fossil fuels, and here is carbon dioxide emissions today. Can you see this staggering increase over here in just the last 200 years? Now, if that continues, then things are very dangerous indeed, and that's the bad Anthropocene. Today, we humans are so powerful that what we do in the next 50 years will shape the future of the entire planet and biosphere. And I believe that young people really need to know this, and that most modern teaching does not teach this adequately. So let me just give some crucial data. For the first time in 4 billion years, a single species dominates change in the entire biosphere. We are living at a turning point in planetary history. It's like an explosion of change in planetary history. Let me give 3 basic but powerful measures of how powerful we are as a species. The first, our impact on the biosphere. We're transforming the global climate system, as we've seen. We're heating up the oceans. We're changing the way carbon and nitrogen circulates, and we're even changing the way the Earth spins on its orbit, because as glaciers melt, water is redistributed around the surface of the Earth, and we can even detect tiny changes in the wobbles of the Earth's orbit. We're changing the biosphere. Secondly, our destructive power. 200 years ago, the most powerful human weapons were cannon. In 2020, we have enough nuclear weapons to degrade most of the biosphere in just 24 hours. We humans have the power to ruin the biosphere. That's a measure of how powerful we are. And one final measure, our impact on other species. The best measurements today suggest that in the course of human history, we have reduced the total mass of living organisms in the biosphere by 50%. Most of that is through deforestation, because forests are where so much of the biomass of life is locked up. Now, I hope you agree, these are very, very powerful measures of our power as a species. No species that we know of in the history of the planet has had this power. We are a planet-changing species. So I have a nightmare periodically. Someone taps me on the shoulder in this dream, and I wake up and I'm staring at something like this. And someone says, "Captain, we're approaching LAX. Are you ready to land?" And I stare at all the dials and levers and I think, I haven't a clue. Which dial am I supposed to look at? Which lever am I supposed to pull? And this is my terror. Can we help our students control the vast machine that we have created in the last 200 years? Because they're going to be the people sitting in the cockpit trying to land this machine safely for future generations. Now, let me end by talking a bit about big history. There are lots of resources for learning big history. And I believe, by the way, that many Montessori schools are using these resources to update Maria Montessori's story. Here are just some of them. Macquarie University has created a new free online syllabus with 3 syllabi, one for junior schools, one for high schools, and one for students just about to enter university. It's still in its early stages, but there's the link. Big History Project is funded by Bill Gates. And there's the URL. It's now being taught, Big History is being taught through the Big History Project in about 2,000 schools. This too is a free online course. Most of them are in the US, about 200 are in Australia, and there are some in other countries, but any school anywhere in the world can use them, though of course all the resources are in English. There are lots of books and online resources on big history, and there's now a scholarly association, the International Big History Association, and its website has a list of resources if you want to look them up. Let me end by saying why all of this really matters to me. That's my grandson, Daniel, over on the left, and my granddaughter, Evie Rose, and that's their dad, Joshua, my son. Their generation will need to know this story because they're going to be in charge of this huge machine we've built. They're going to face the challenges of living in the Anthropocene and trying to manage an entire planet. And that's why they desperately need to know how we got to this point in human history. Because if they do it well, they will create a better world for future generations. For my great-grandchildren and great-great-great-grandchildren and yours as well. I thank you for your attention.
Thank you so much, David.
Okay, I'll stop sharing. Okay.
Mm-hmm. So a couple of questions about the idea of collective learning.
Right.
Because you on the websites and on the course, it talks a lot about collective learning, the ability to pass knowledge on to generation after generation. But one of the things that Montessori felt was really a problem was that the collective learning was just dumped on children. Sort of, this is what we know now, and this is what you have to memorize now. And as this knowledge accumulates, it just becomes more and more and more to memorize, without any sense of how that knowledge was accumulated. So one of the reasons that she developed her materials was to, and demonstrations and things, was to try to help children have a guided reenactment of how the knowledge was actually acquired, and not just, this is what we know now, so here it is. Yeah. And how would the big history approach help with that process?
Well, look, first, can I say that the idea of collective learning is, in a sense, kind of neutral. It's an attempt to explain what it is that makes us different. Now, I hope I've persuaded you that we really are different. There's no species, in some ways, we're very similar to chimps, to bonobos, very similar indeed. But these cultural differences make us radically different and vastly more powerful, and in some ways dangerous. So collective learning is my best attempt to explain why we're different. Now, when it comes to education, of course, and now you have to start asking moral and ethical and pedagogical questions. The idea of collective learning simply says that knowledge tends to accumulate in the species, whether it's good or bad, it just tends to accumulate. We as teachers, of course, and any teachers have the moral responsibility of trying to shape that knowledge in ways that help young people face the challenges they face. Now, I believe, of course, that big history is a powerful way of doing that. And I'm sure Maria Montessori felt much the same about, you know, cosmic education. You talked about teaching students how the knowledge is acquired. Now, I've just tried to describe the big history story in about 20 minutes. So, you know, I've skipped all of that. But in our actual teaching, we spend a lot of time talking about how we know these things, how trustworthy this knowledge is, why, even though we can never assert with absolute certainty that something is true, given the choice between different ways of understanding the world, this is probably the best bet. I mean, debates about climate change are a wonderful example about this. Now, why should people take climate change seriously? Well, it's worth leading people through the very elementary chemistry about this. You know, it's a greenhouse. These create greenhouse. So if you put glass over the whole surface of the earth, everyone understands that things would get uncomfortably hot. Well, the metaphor of the greenhouse gas is saying you don't need to understand all the chemistry, but what you need to understand is the effect of having a lot of greenhouse gases in the atmosphere is similar to building a sort of greenhouse over the whole earth. So we spend a lot of time, and I agree completely, it's immensely important that students are not just handed information and told it's true, but they're also helped to understand why it's true. And we have a lot of sort of gadgets on the Big History Project to help people challenge information. We call them claim testers. So we train students in the Big History Project. Someone says something to you. Now, you apply the claim testers. You say, what's this knowledge based on? Is it based on authority? Is it simply, am I believing it simply because it's my teacher? Is it based on logic? Is it based on evidence? Or is it just, do I just buy it because I like it? No. So we get students to ask these questions about all knowledge. Why am I trusting this knowledge, or why am I not trusting it?
So in this idea that this in knowledge is really, really important. But it doesn't seem that knowledge itself is enough to keep people from misusing the great power that comes with that knowledge.
Sure.
So how, when you're working with the Big History Project, how do you combine knowledge with ethics in some way, so that you don't get the sins that Gandhi talks about of just knowledge without compassion and so on, that means that knowledge actually becomes a weapon of power, as opposed to something that leads to a good use of this Anthropocene.
Yeah, look, I personally, so this comes down to my personal beliefs as a teacher, really. You can be overambitious. I believe that telling this story itself is powerful. Now, there's no guarantees that people are going to understand it fully, that people are going to interpret it correctly. There's also not even any guarantee that I'm telling the right story. The best I can do is to try to ensure that my students understand a story that I believe as a teacher will help them get their bearings in this world, and will also help them to know how to act if they decide that it's important to act for the good of other people and perhaps for the good of future generations. I'm acutely aware of the limits of the power of a teacher, and in a sense, I wouldn't want my powers to be too great, because we've seen the dangers of what happens when teachers become too powerful. I'm a historian of the Soviet Union. I lived in the Soviet Union for a year, and there was a society in which the possibilities of questioning your teacher were less than in the society I grew up in.
Do you think that there are some Goldilocks conditions now for human beings to actually take hold of the power that they have in a different way than when we first started using fossil fuels?
And collective learning itself is the crucial thing. We're learning so much. When I was at school, no one understood anything about climate change. We have learned so much. The models have got so much better. The science is so much better. So in many ways, and I think many people would agree with this, many scientists, we have the tools we need to build a better future. The most unpredictable area of all, and at the moment I'm trying to write a book on the future, I'm thinking a lot about this. Most unpredictable component in all of this is human beings. You know, the chemistry is pretty regular. The physics is pretty irregular. What's irregular is the behavior of human beings, and particularly of powerful human beings, because powerful human beings can turn millions of other human beings in a good direction or a bad direction. So I think we have all the tools we need. My own personal belief is that teaching a story like this is a modest way of putting in your own contribution to tipping the balance in the most positive way.
Great. So I don't have anything else other than, like, I could talk to you for another 10 hours, but I'm sure that would not play well on Zoom. But I want to really thank you for your talk. I think it's a very important view that all Montessorians should really learn about what you do in this global project, because sometimes we felt a little bit isolated in the educational community because of our view of both human nature and the vision of the universe that Montessori wanted us to work with the 6 to 12-year-old from. So I think this gives us another set of powerful tools to help empower both teachers, administrators, and parents who choose to send their children to a school that really embraces this vision. Thank you so much.
Well, that isolation I understand very well, because big history has really struggled to be accepted, because the modern knowledge is so much dominated by the idea of disciplines. And this breaks those rules. So I understand the isolation, but let me also thank you and Nina and Miroslava for inviting me to talk. I love talking to Montessori teachers because I feel there's a real alliance there. And my hope is that maybe many Montessori teachers will find it productive to check out the big history story. They won't agree with everything, but they may find a lot of useful resources. And I do know already that quite a few Montessori schools are using big history materials, and both the websites I mentioned are completely free. All the material there is free, freely available. Yeah.
It's wonderful. Thank you.
Okay, so thank you, the both of you. This, like Carlos said, I could listen to both of you for quite some time. I think it's very interesting, and both from the Montessori perspective and your perspective, David. It's really nice to hear this from both sides, and interesting perspectives from both. So thank you so much for the talk and for your questions, Carla, and thank you to those of you who are watching. Okay, thank you.